tossing a coin. So if we want to construct a probability distribution for the sample space when we toss a coin 3 times, we're going to let x be the number of heads that we can get. So if I'm tossing a coin 3 times, what are the options for how many heads you can get? 3. What else? 1, 2, 3, or 0, because you could get all tails. So the options for the number of heads would be 1 through 3. Now I need to figure out the probabilities that go along with that. If I'm tossing this coin 3 times, and each time I have 2 options. I can get a head or a tail, and we're doing it 3 times. So 2 to the 3rd tells me how many things are in my sample space. So there should be 8 options in there. Of those 8 options, how many of the ways are you going to get absolutely no heads? 1, because you're going to get all the tails. So 1/8 is the way that I'm going to get no heads at all. How many ways are you going to get all heads? Same thing, 1/8. So that's 2 of your options in your sample space. Now there's 6 remaining. Out of those 6 that remain, how many ways are you going to get 1 head? 3. And how many are you going to get 2 heads? Does that probability all add up to 1? Yes. Questions on that? That is including 0 as an option, because think about it. We've got the option where we've got tails, 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 heads, heads, and heads. Oh, I guess this is also going along with order matters. You have heads, tail, heads, tail, heads, and heads, heads, head, tail. Or you could have tail, tail, heads, tail, heads, tail, or heads, tail, tail. So the 8 options or different combinations we can come up with includes both the 0 and the 3. Other questions? This is really the only portion that was your answer. All right. Who's a baseball fan in here? Anybody? Sort of? Football? Yeah, that's true. Well, don't worry. I don't really know that much about baseball either. So, Baseball World Series is played by the winning of the National League and the American League. The first team to win 4 games wins the World Series. In other words, the series will consist of the number of games depending on the individual victories. The data should be shown actually. I keep forgetting to change that one. Shown consists of the number of games played in the World Series from 1965 through 2005. There was no World Series in 1994. The number of games played represented by the variable x, and the probability p of x for each x. Construct the probability distribution. All right, so we know we've got our x, and then we have the frequencies of those x's. What happened to the games 1 through 3? How many games does it take to win the World Series? At least 4. It's the best out of 7. So we don't even consider 1 through 3 because you can't win with just those games. So these are the only options in order to win the World Series. And if I know my x's and I want to try to figure out the probabilities that go along with them, what can I do? What do we think the probability would be that the World Series will be won in 4 games? We're going to have to base it on the data that we've got, though.
Are you looking at
Not quite. I want to use the numbers they gave me. So let's base it on the fact that there's been 8 games out of the 40 that were won in 4 games. How about 5? 7 out of 40. 6? 9 out of 40. And lastly, 16 out of 40. Does that add up to a total of 1? I hope so. And we can turn it into decimals again and kind of look at it that way. We'll use the numbers a little bit more later. All right, just for fun, why was there no World Series in '94? There was a strike, a player strike, so they didn't have a World Series. I didn't actually know that. I don't know anything about baseball, but my husband played in college, so now I know a lot. Back to the dice. We had that probability distribution above. So I want to find the expected value for the number of spots that appear on the dice. So spots is just what number shows up on the dice. So if we look back at that distribution, well, actually I'll just put it here. We already have it back before. But 1, 2, 3, 4, 5, and 6. And these were all 1/6. Then I want to follow my formula to find this mean. So the mean is going to equal, we multiply across that line, 1 times 1/6, and then we add them all up. 2 times 1/6, plus 3 times 1/6, plus 4 times 1/6, 5 times 1/6, and 6 times 1/6. So let's multiply and add those up and see what we get for the mean. All right, so 3.5, and we all agree. So the mean number of spots that appear on a die is 3.5. Now you might say that's not possible, right? You can't have half of a dot on a dice. But this is saying you've rolled the dice a bunch of times and it's just the average number that comes up. It's not saying that is the amount you get. It's just saying if you do it a bunch of times, that's about the mean that you're going to get when you go through it. Questions on that? All right, so like it was brought up, this can be done in the calculator. I'm going to put my x's in a list, and I'm going to put my probabilities in a list. So list 1 and list 2. And then we can run a 1 var stats on our L1 and our L2. So let's try that. You can turn them into decimals first, or when you type it in, it will also do it for you. So x's are from 1 to 6. And your list 2 will have all 1/6. And if you do 1 divided by 6, it'll convert it to the decimal for you. Bless you. All right, once I get my data in, I'll go over to calculate and 1 var stats. You want to tell it your X list first, so wherever your X list is, and then tell it your frequency list, which is your probability list. And if yours just pops up 1 var stats, do L1, comma L2. And when we calculate, we get back to 3.5. Which is good, because we at least agree with what we did by hand. Questions on that? So x and p of x. All right, if x is the number of girls, what are the options for the girls? For how many you can have? 2 girls, one girl, and no girls. All right. Now, how many options do we have in our sample space total? If there's 2 options, you can be a boy or a girl, and you're having 2 kids. There's 4 total options. How many of those 4 would give you no girls? Just 1. How many give you 2 girls? So that leaves how many to give you 1 girl? 2. So you can say 2/4, you could say 1/2, either one, or 0.5, whatever you want. We can actually turn these all into decimals too, and it should work the same. All right, so if I want the expected value of this, we can either multiply across and say 0 times 1/4 plus 1 times 1/2 plus 2 times 1/4. Or you can put them in list 1 and list 2 and get your mean from the 1 var stats of your L1 and L2. So let's see what we get for that. We're not too surprised that it's 1 because you have a 50-50 chance of getting a boy and a girl. So we would expect that you would get 1 on average when you have 2 kids. Questions on that? No? Since we already know we can get this on the calculator, I'm going to show us how the formula would work, just so that we have it. So, I'm going to find the variance first, and the variance formula said that you would take the x's and square them, multiply them by their probabilities, and then add all those together. So we'll start there. We'll say 1 squared times 1/6 plus 2 squared times 1/6, 3 squared times 1/6, 4 squared times 1/6, 5 squared times 1/6, and lastly 6 squared times 1/6. Now I want to add all of that together, and then we're supposed to subtract the mean squared. What was the mean of this? 3.5. So we're going to square 3.5 and subtract it at the end. And let's see what we come up with for this. Did anybody find the variance? Not quite. You should get around 2.9, depending on where you round. 2.92. So if I have the variance, how can I get the standard deviation? Take the square root. So 2.92 square rooted gives me 1.7. Oh, 1. Were you typing in the whole thing? It's probably something with parentheses or something. Yeah. All right, questions on the formula?